These notes go as section 9.4 in your textbook. Remember that we had a definition of an irrational number that said this was a number that could not be written as the ratio of integers. It's useful to know that in their decimal form, irrational numbers don't repeat and don't terminate. So the decimal form of an irrational number does not repeat and does not end or terminate. A real number is what we get if we put together the set of all rational and irrational numbers together. Now you might ask, why would we bother describing numbers as real? Are there such a thing as numbers that are not real? There are. There are numbers that we describe as imaginary numbers, and you'll work with them. They actually have some very practical applications in measuring the electricity flow through circuits and in modeling certain equations. You'll use them when you get to Algebra 2. For now, let's work on classifying some real numbers. So in this first row, I have this decimal, 0.7. I could write it as 7/10, and if I simply speak that decimal form aloud, it's 7/10. Decimal type, this one is terminating. It ends. It's 0.7 and it doesn't continue on after that. Any decimal that is terminating is a rational number. Next, I have 2/9. If I take 2/9 and I want to write it in its decimal form, 2 divided by 9, I get this repeating decimal. I get 0.2 repeating. So the decimal type for this one is repeating. Anything that is a repeating decimal is also rational. We learned in a previous section how to take a repeating decimal and turn it back into a fraction. It was a fairly complicated process, but we learned how to do it. All right, last, the square root of 5. So I bust out my calculator and I take the square root of 5 and I get this number that doesn't repeat and doesn't have a pattern. So to write this down, I'm going to write what I see on the display, 2.236067978. But I'm not going to just end it there, because this square root of 5 doesn't end there. It's just that my calculator's display ran out of room. So I'm going to put a dot, dot, dot to indicate that those numbers keep on going. I don't put a bar over any of them because they don't repeat. So we would say that this is non-terminating, it doesn't end, and non-repeating. This is how we know this is an irrational number. If you do a Google search for the square root of 5, you might find a page that has hundreds and hundreds and hundreds of decimal places shown, but you could keep going forever. This is not a rational number. I can't reduce this to simply a fraction that has an integer on the top and an integer on the bottom. All right, so let's say that I want to compare an irrational number, the square root of 3, with a rational number, 6/5, to find out which one's bigger. Well, personally, I'd throw these both into my calculator and find their decimal form. So if I were to find the square root of 3 is approximately 1.73, and if I take 6 divided by 5, I get 1.2. Now I can tell for sure which of these is bigger. The square root of 3 is bigger than 6/5. What about over here? -3/2, I can turn that into its decimal form in my head. 3/2 is the same as 1.5, so -1.5. And this negative sign here means the opposite of the square root of 3. Well, I already found that the square root of 3 here is about 1.73. Remember when we're dealing with negative numbers that the one that has the smaller absolute value is actually a bigger number. Maybe it's helpful to think of these if we put them on a number line. If 0 was out here on the number line, negative 1.5 would be here, and negative 1.73 would be further in the negative direction. It's actually a smaller number because it's more negative. When it says use a number line to order these from least to greatest, I would suggest we draw a number line that has 0, 1, 2, 3, etc. 0, negative 1, negative 2, and negative 3. And let's turn each of these numbers, the square root of 6 over 2, negative 2.2, 5 over 2, and negative 2 times the square root of 2, let's turn each of those into their decimal approximations or equivalents. So the square root of 6 over 2. First, I take 6 and find its square root, and that's that ugly number, and then I divide that by 2. This gives me something that's approximately 1.22. So I would put that on my number line about there. So this is the square root of 6 over 2. Negative 2.2, I can put that directly on my number line. Negative 1, negative 2, it's a little more negative than 2. It's about there. That's negative 2.2. 5 halves, 5 over 2, that's the same as 2.5. Its decimal equivalent is right here. So that's 5 halves. And negative 2 times the square root of 2. I need my calculator for that one again. So I'm going to take 2, that's this 2 I entered. I'm going to take its square root, I get that. I'm going to multiply that number by 2. I get 2.83 approximately. And then don't forget the negative sign out in front of it. So this one is approximately equal to negative 2.83. Where does that go on the number line? Well, it's even more negative than negative 2.2. It's down here. That's negative 2 times the square root of 2 there. So now we have, along the bottom here in this number line, we have these numbers in order from the smallest up to the biggest. All right, so let's take a look at the bottom. Are these two numbers in here? Which one's rational? Which one's irrational? Are they both? Well, 8/11 is rational. It's the ratio of an integer on the top and an integer on the bottom. So it's rational. The square root of 7, 7's not a perfect square. Whenever I take a square root of something that's not a perfect square, I always get an irrational number. All right, now I need to put a less than, greater than, or equal to sign in here. The square root of 10, let me use my calculator to do that one. The square root of 10, 3.16, which is less than 3.5. And the would you rather is clearly entirely up to you. When you're working through the next page in your packet, let me just do an example for you to show you how I'd like you to do this. So in this table, on the left-hand side, we have some rational numbers, and on the right-hand side, we have some irrational numbers. The process we're going to use is the same no matter which chart we're using. So on the left-hand side, our original form of this number is 1/3. If I write it in its decimal form, if I bust out my calculator and do 1 divided by 3, or if I just remember that 1/3 is the same as 0.3 repeating, this decimal form helps me figure out where on the number line this should go. So 0.3, let's see, it's between 0 and 1. It's going to be right about here. But I'm going to label that point not with the original form, but with the decimal form. And I'm going to put the rational numbers up above the number line. So I'm going to label this 1/3. There. Now let's skip over. The original form of this number is the square root of 2. Its decimal approximation, it's approximately 1.4. So if I were to take my calculator and take 2 and take the square root of it, it's approximately 1.4. I can find that on the number line. 1.4, that's a little less than 1.5, which is 1.5. 1.5 would be there, so 1.4 is going to be about there. This is an irrational number, so I'm going to label it below the number line, and I'm going to write the original form, the square root of 2. Not the decimal form, but the original form. So you need to go through and finish this for both of these columns.